All right, welcome, welcome. We're officially recording. I think it's like the 19th or something like that here. So today we're going to build our own Python program from scratch. And I think a lot of times, and I'll let you all point at me here for a minute and then we'll look at this. I think a lot of times some of the challenges with programming is there's really going to be a big paradigm shift in terms of how do you write a program? Because I think I've had a lot of challenges this week where folks are emailing me like these big paragraphs of stuff, and I'm like, I don't know, I don't even know what you're doing here. And so I want you all to kind of get into my mind because I'm not a programmer per se. I know how to use this data, and I know I'm not a good programmer, I'm a good enough programmer. And this is what I all want you to do because we're taking this big leap from small basic to Python. Now, I heard a lot of people liked small basic. Why'd you like small basic? Just simple and it was easy and all this other good stuff, but it doesn't really interact with anything else. So we can't really integrate it with anything else. Now you can open files and read files and write files like CSV files, which are just spreadsheets, but we have these library called ArcPy that has specifically commands to interact with our ArcGIS Pro software. When we looked at a couple of them, we've got the for loops and all this other good stuff here that we can have, but we looked at one specifically called add message. And so within our little geoprocessing right here, it just popped up some messages right here. So a lot of times people start putting together code and then all of a sudden, like it doesn't work, and like I don't know what went wrong. And so one of the things we're gonna do was like we're gonna build a program from scratch that does three things. It looks a lot like what you're gonna see and what we looked at last week, very similar. And we're gonna write a program that just asks the user for a number. Now in small basic, how do you ask a user for a number? What'd you do? You don't have to say the right line, but what was called read text, read number, something like that. And this is what we call syntax. So you just type in a number and you do that. Next, we print out the factors. Okay, so numbers like 14. What are examples of factors of 14?
7.
Yeah. 2, 7, 1, and 14. Or, if we want to count 1 and 14 with those. And 3, it just count the number of factors. So something like 14 technically would have 4 factors. So basically prime numbers, 2 and above basically there are numbers that only have 2 factors. If you want to, we can see if it's prime or composite, all that other stuff we already did. So, but we're going to do this within Python. And so what I started doing here, and I'm going to and so those of us joining us online, you can kind of see our goals here. Let's write a program that asks the user for a number, prints out the factors, and counts the number of factors. Now, I said 14. What might Chantel type in? You gonna type in 14? No. 99, 80 million, whatever. And so those are what we call variables. Okay, so we got the variables. So what we're going to do, we're going to go through Mulrooney, how he does this. Okay, and hopefully you're all going to follow along, or if you want to open up your ArcGIS Pro and start doing this. And actually, I'm going to click the little delete button right here and start from scratch. Oops. Okay. We're going to start from scratch right here. And I think I'm sharing my screen so everyone online can see this. And so right mouse click, I'm going to delete you. Sure. And so now when I get to my hello world or my toolbox, I can right mouse click and I can make a new script. We're just going to run this. Now, someone emailed me before that they weren't able to add new scripts. I don't know how or why or whatever. And so if need be, you can make yourself a new toolbox and then add a toolbox to the script. I don't think I had any read protections on it. I'm not really sure. So if you need to, you can make a new tool set. And I think a new Python toolbox, that's what Chima was mentioning. So you could put I believe you could put multiple tools within it if you really wanted to. That's starting to get a little out of my skill set because basically I just want to run a little program that does this. Because the assignment that we're going to do today is we're going to do something called the null value checker, meaning we want to look for a field that has all values of nulls. Now, how many times are we going to go through? 100 times, 50 times, 90 times, however many times, however many records there are. And so in the hello world, we're going to right mouse click, and I'm going to click new script. Okay, now what's the name of the script going to be? I'm just going to call it factors. Then I'm going to give it a label called factors. And click OK. Okay. And watch what happens. It's got no input parameters. Why doesn't it have any input parameters? I never specified anything exactly. So we're going to start building these from scratch right here. Okay. And I can run the little thing and I guess it's going to run. Now what we're going to start doing is we're going to start adding some code to this thing here. Okay. And the one thing, and so I'll go to my little catalog and I can right mouse click. I'm going to click edit. And when I click edit, look at all the code that comes up right here. I'm pretty smart. I already wrote all this stuff. This is auto-generated. Me, the way that I debug stuff is using like print statement. Basically, hey, if I can get to this point in print statement right here, guess what? My program hasn't crapped out on me and I'm here. So right here after this script tool, what's the print statement that we use? Do you remember? Because remember, we had like write line. It was something like text window dot write line. And this is where we get into the syntax. But if we don't know, I'm going to type in argpy. Now, what does this argpy mean? And I want someone besides Chima to answer. What's argpy mean? Argpy. Exactly. This is the set of this is a library. Okay, these are all commands that Python commands that ArcGIS Pro is going to understand. Because like for and print and all these if statements, anyone's going to understand that. So these are going to be speaking specifically to ArcGIS Pro. So argpy.addmessage. What do you think argpy.addMessage means? We're going to create a message. What message do we want to put in here? Yeah, put out whatever we want. I'll just put right here. Okay, parentheses. Hi, Mom. Oops. I need to spell the word mom correctly. Okay. Why did I put it in quotes? It's exactly, Barbara. Exactly what I want to show. I don't want to show it. Do I have any variables to print? And first of all, no, there's no variables. Basically, I'm just going to run this thing to make sure it actually runs. Okay. And so I've got my code right here. I know a couple people were running into some problems here where the editor wasn't talking to the ArcGIS Pro, and I'm not sure why. We can kind of work on that if need be, but I'm going to kind of keep both of them open at the same time as we kind of work through this. So I'm going to click Control S, and now under Factors, I'm just going to click Open and Run. I got a green check mark in the bottom. If you get a green check mark, that's a good thing. And if I click View Details, what do you see? Start time, Monday, February 19th, 2024. What do you see there? Hi, Mom. Okay, so the program's running. Now we're going to have to start to generate some stuff right here. Okay. And if I wanted to, I'll put something like, hi, Dad, exclamation point. Now I'm just going to click Control S to save it. Run it again. And I've got a new thing. a new window that pops up, and you can see hi mom and hi dad. Yes. It's already there. So and basically we're just running the code right here. That's all we're doing. And so if we look a little more specifically here, if we look a little more specifically here, and Ariel had a really good question. If we look at properties and I click on like parameters, execution, you can see the code right here that's also attached, right? So I really want to, I can cut and paste code into there, but you can see the program that's going on right there. It's embedded. Okay, I can link this to a file sitting in some other place. I can use different editors or whatever here. Okay, so, and just for the heck of it, I'll put like, hi, kids. And just make sure these are all what we call literals. And I'm gonna hit Control S, which means just save it right here. Open and run. And there we go. Hi mom, hi dad, hi kids. So it's basically just running that code there. Okay? That's the one thing that I like to do. This is, you're getting into the mind of Mulroney. Meaning, this is how I build a program. All right, I got this code going, because once the red check marks start disappearing, is that, okay, I'll add a couple little lines of code here, and then, all right, I'm not going to write 15. I'm not going to write 15 lines of code and hit the run button and say, oh, one of these is messed up. So I'm going to write a couple right here, get to a print statement. If I got the gray, I've got the green check mark, that means we're in a good place right here. I like you. And we can also look for logical errors, because if it's printing out, wrong numbers or whatever, let's see what I did wrong. Okay. All right, next. What's the very first thing that we need? Ask the user for a number. Now, we don't have the document.writeLine. What do we have? What can we add here? What's an input parameter that we can have? What did I have before? I can do files and databases. Let's not work with that stuff. Let's put a little just text box right there, right? Let's just put a little text box and go from there. Okay. And so when I go back here, I'm going to right mouse click and click on my properties. What do I want to add? I'm going to add a little string. What do I want to call it? Number. Name, number. What are we asking for? Type in a number. Okay. Should it be required? I hope so. That's the whole goal of the program. Okay. Whole goal of the program. Okay. So type in a number. Very first thing here. Because here we're going to start getting into factors and all that other stuff here. Input. That means it's an input parameter, because in theory, I could put string boxes here that we could write to. Now, I'm not that talented, or it's easy enough to do that, but stuff I used to do in Visual Basic. But for me, I just send everything to the add message, because at the end of the day, I'm going to be manipulating the database or do whatever. Okay, and so I'm going to click OK. All right, so now when I click on factors, look what I got here. I got a little number right here. I'm gonna type in the number 6. Now what? Oh, whoa. What did I do here? Line 10. What did I do here? All right, I already got my first error here. All right, so file, line 10, get parameter as text. Okay, what seems to be the problem here? Okay, line 10. Let's go to line 10. Let's see what it says.
I was having the same problem. Whenever it has an error, it always says it's on line 10.
Okay.
So I used something another way to find the error. Usually it tells you what the error is. It doesn't give you the right line, but it gives you the right error. So you just gotta find the code. You gotta manually find where it's erroring, but
Okay. I have an idea of what it is. Hmm.
Because we only have one text box, but then we're calling it two.
Yeah. Uh-oh, look what I just did. All right. I got it to run, but guess what? Nothing popped up. All right. All right. So, all right. So if name equals main, what's this thing mean? Not imported. Get parameter is text. Let me try something right here. I'm just gonna run this here. Let's see what happens. Okay, doesn't like me there. File in module. Go back to here. Back to
We could comment out line 12.
comment at what?
Line 12. So just put the pound sign on line 12.
Okay, comment out line 12. All right, let's try that. Let's see if it works.
Line 14.
Okay, let's try that. Good idea. I'm just a little concerned because it ran it the first time. It ran it the first time. Okay.
Yeah, it's 14 now. If you comment line 14 now, it should.
Okay, cool. That's a good idea. All right, so 14M. All right, so what'd we do? We just commented those out. All right, so parameter 0 equals arcpy dot get parameter is test 0. Because how many parameters do we have there? 0. Because at some point in time, we're gonna have like multiple parameters we bring in. And so once we created a parameter, what was the parameter that we created called? Number. Once we created a parameter that was number, the program says, all right, I got 0, but where's 1? You don't have 1. And let me just make sure Andy's right, because if he's not, we'll just blame him. And no, I'm just kidding. All right, cool. What do we have here? So let's just see what we did, see why we did it. There's a lot of just trial and error right there. Okay, and I'm also recording this so we can kind of go back and revisit this. And so all I did was Andy's suggestion was get rid of parameter 1 and then the script tool param1, param0. Let's comment that out because at the end of the day, what do we want? The red, we want the green check mark that runs. Get that green. So we commented those out once we started adding parameters. Because we might want to create one that adds 2 numbers, right? Yeah, like, hey, text 1, text 2. All right, next, what do we want to do? What number did you print out? You want to print out something you printed out? Do you want to print out hi mom and hi dad again? No. Okay, so add message. The number that you printed out was oh, cool. Param 0. So now I'm gonna print out a message that is a concatenation. That's just a big fancy word, way of saying the number that you printed out was plus param 0. Is it gonna print out the word param 0? No. What's param 0 gonna be? 6, 87, 43, whatever you, that's called the variable. Now we're gonna have to do something to that param 0 here in a second. We might have to do something to it in a second. Now, so when I run this, what is it gonna say? I'm gonna run it. Let's view the details. Okay, cool. The number that you printed out was 6. What if I type in 45.5? What do you think it's going to say? Number that is printed out was 45.5. Now, that's going to be a little bit of a problem coming up, right? Because we're just looking at factors of numbers. What's to keep you from saying, writing out text or whatever? We're not going to get too much into that. Now, does this start to ring a bell with small basic, where we're kind of combining literals with variables, with literals and all that other good stuff? Exactly. Hey, the factors of my Pythagorean theorem are this and this and this and this. Okay. More number. What's this? Param 0. Okay. We gotta get parameter first, and then we'll number. We got I guess.
Yeah.
The whole. It's all this stuff. Yeah, mine's like, I mean.
Oh, okay. Let's blame you for that. Okay. All right, so we've been helping everyone out here. We got it running here. We're got kind of a method to the madness right here, and I don't want to be. All right, so next thing we want to do here, we've printed out a number. We've done a couple of things here. We added a we added a parameter. So when I go to properties, I added a parameter. It's called number. It's required. It won't let you do anything until you do it, until you type it in. And when we run it, it'll print out the actual number that we have using this message. Okay, so here's my output. The number that you printed or typed in was 45. All right, next, we want to figure out the factors. What we have to do, I typed in 45. How do you figure out if something's a factor? How do you figure out if something's a factor? Divide it by every number between 1 and 45, and if there's no remainder, then it's a factor. We all know what a remainder is, right? Okay, so like 45 and 2, it's going to have a remainder of 1. Does it matter what the remainder is? No, it doesn't matter. Who cares? 45 and 5, does it have a remainder? 0, or it doesn't have a remainder. That's all we're going to do. So we're going to put it into a loop, right? Okay, now this is where we're kind of making some leaps here. And so I printed out the ArcGIS Python. I printed out a couple of these things here for loop. Okay, I'm just going to go down to the for loop and look what I have here. I got a nice little if A is great. Does that ring a bell right here? But we're going to go to a little loop here. Here's a for loop. Look what I can do here. So all I'm going to do is go through a loop because we're going to see if 45 and 1 have a remainder. 45 and 2 have a remainder. 45 and 3 have a remainder. What are we going to go up to? 45, exactly. All right, so I'm just going to use this. For I in range 1, comma 10, colon. You know what I'm going to do? I'm just literally going to just use this, put it in my code here. Okay. So I'm going to type exactly what it has right here. All right, next, I'll keep this print statement here. So for I in range, what's the first number that we start at? 1, comma what? 45. And one thing I'm going to do right here, now what do we call it? Do we call it 45? What's the variable that it's stored in? What's that variable? Because Chantel might have typed in 16, 87, 423. What is it called? Param 0. Could you call it whatever you want? Call it whatever you want. Why did I call it param 0? That's what the computer gave it. I'm not going to mess around with it. Param 0. Now what goes after the loop? A little colon. What do you want to see to, what do you want to do to make sure this loop actually works? ArcPy dot add message. Hi. So what do you think this program is going to do? What's Mulrooney thinking here? What am I thinking? Have we done anything with factors yet? Nope, not at all. So this is what the loop looks like for I in range 1, comma param 0. What do you think arcpy.addMessage I does? What's I? The first time it goes through the loop, what's I? 1. What's the second time it goes through? What is it? What the third time? How many times is it going to go? How many times, Ariel? However many you put in the little box, right? 100, 1,000, million, who knows? Yeah. You got it. Okay, all right, let's see if this thing runs. I'm gonna hit Control S. Let's see if it runs. Let's see what errors we get. All right, so now I'm gonna run. I typed in my little 45. Okay, uh-oh. I knew this error was gonna happen. Uh-oh, we might have to read the actual directions here. Okay. String object cannot be interpreted as an error, as an integer. When we input this thing, we called it a string. What's a string? What'd you say, Mac? What's a string? A line of text. It could be my last name. It could be your street or whatever. Can we count from like 1 to my street? No, we can't count from 1 to Windswept Drive. Why? Because well, Windswept Drive is not enough. And so when you put in that string right there, remember for that input parameter you said string? And so we need to change this to an integer. We got a nice little command right here that says, we'll just put a little button called int. You know what? I got a better idea we could do. We're going to put int integer. Now you see what I did up at the top here? Those of you joining us online, I put int integer right here. What did I just do? What do you think I just did, Michael? What does
Cast it.
int do? I convert it from a string to an integer. So I convert my 820 number from my 820 number to some really long number. Right? Now, why did I do that? Well, the thing told me, it just said, remember last week we were talking about the different types of strings and types that we can look at? I didn't see. No. Oh. The other way, other direction, sorry, my fault. My fault, I'm trying to be a little too cute here, sorry. It should be right here, int, get parameter as text, my fault, I'm sorry. I was jumping ahead of myself. Okay, so param0. Let me go back here. Uh-oh. Parameter 0 is equal to the integer. We're going to convert whatever we typed in, that 45, to an integer. So even something like 45.5 is going to round it up to 46 or truncate it or whatever. So let's try running it again. Can only concatenate string, not int to string. Huh. What do we do here? Let me try something here.
Do you need to specify I as an integer?
No. Line 13. Here we go. Okay. All right, so I got it to run here. Benjamin had a good idea, but what I did here was it didn't like me putting all these in the same place. So I might put something like number equals int of param0. And I'm going to put a command right here. And so when we download these and when we're working with these in class, you can see exactly what I did. What's the whole goal of this line here? And I'm going to put a comment here. So when you're working on this later, what's the comment here? What do you think I just did here, Barbara? Exactly. I get the value from the input parameter that you typed in. What's this line mean? Number equals int param. All I'm doing is converting the value that we took in to a integer. And then what am I going to do with this loop here? Go through the loop number times print out the number. Then right here, I'm going to say print a message that shows what you printed out. I'm going to hit Control S. I want to make sure this thing runs. There we go. Okay. How many times did it go through this loop? A lot. Does everyone like the commenting that I did here? Do you see why I did this? Okay, good. This is a method behind my madness, so we can kind of go back and revisit this here. All right, so I'm just going to go through a loop, number times, and then I'm just going to print it out. So what if instead of 45, I typed in 2,000 here? What do you think's going to happen?
Might take a little longer.
Might take a little longer to run, exactly. How many messages do you think I have? 1,999. I assume it's gonna, we can, yeah. And you notice when I typed in 2,000, it went up to 1,999. So what did I do? I just added one to this loop to make sure it would go here. Okay. How do we feel about that? We get the idea here? Do we like the, can you see the comments, what I'm trying to do here? If I were to cut and paste and put this in the announcements, can you see what we would do? All right, so next thing we want to do. What do we want to do? We want to figure out if something's a factor. Did I print out all the factors the first time I did it? I didn't print out all the numbers, right? 1, 2, 3, 4, 5, 6, 7. Why did I do that? Just to make sure you could show that I went through the loop here. I don't want to print out all the numbers. So I'll put a little thing right, I'll put a little hashtag right there. Comment this thing out too. All right, now this comes kind of my big thing that we want to look at. So I heard Max say something about a remainder. Okay. Okay. I've got this little thing called the percent sign. Did we do the percent sign at all in small basic? Or did we do just remainder? Yeah, remainder. So now what are we gonna do the remainder of? The remainder of what? The number that you typed in, what's the number you typed in? 1743. What variable is that called? What do we call it right here? Number. What's a potential factor? I'm trying to see if 45 and what are factors? What do we call it? I. Is 45 and 1 a factor? Does 45 and 1 have a remainder? Does 45 and 2 have a remainder? Does 45 and 3 have a remainder? Does 45 and 4 have a remainder? Does 45 and 5 have a remainder? You get what I'm getting at? Do we want to print out a nice big statement that says, hey, let's print this thing out? You want to do that? Well, we'll try that. And so we'll make a little fact, something here called remainder equals what? Number modulus I. Now, what did I just do right here? I created a variable that represents the number, and whatever number is in the loop, right? What's the first number in the loop? 1. What's the second one? 2. What's the third one? 3. What's the fourth one? 4. Hey, do you want to print out a statement that shows us where we are that says, hey, the remainder of number and I is remainder? Did we do this in small basic? You bet we did. So, didn't we already do this up here too? Why don't we just do this? Cut and paste this thing right here. What am I going to do? Type in the remainder of plus number and plus I is Do you think I'm going to have to convert these to string, Chima? In this, I probably will. Now, the one thing that I mentioned, remember in small basic, we can kind of combine numbers and strings together? Okay. Here, this is a little bit different. So these things in blue, what are these things in blue called? You starting to see what is this number in blue? Those are going to be our variables. And then we got our commands. What's in that purplish red thing? Those are our literals, our strings. And just for the heck of it, I'll run it. I'm going to get an error and watch what it's going to say here. We can't go between strings and numbers. Sorry, we're not small basic. So all we're going to do here is just put the word str around the little number. Str here. Right there. So this str, all it means, it says converts it to a string because it's sitting there saying, hey, I want to add the number is plus 23. And it's treating 23 as a number. Can we add strings and numbers? Of course not. We can't add nominal and ratio data. So what do we say here? Explain. This is a message that adds the string right here and converts any number to a string so it can be concatenated. What's this big concatenated? What's this big fancy word concatenated mean? Adding joining strings together. Well, let's try running this thing. And I'm going to put this as 45. Oh, look what I did here. Cool. I'm missing some spaces here, but the remainder of 45 and 1 is 0. The remainder of 45 and 2 is 1. The remainder of 45 and 3 is 0. This is pretty cool, right? This is neat. This is the way I go and build programs here. I run it, write a line, hit the print statement. Does this look right? Yeah. No, not exactly right. Because eventually, are we going to have all this stuff here? Not necessarily. All right, let me type in 1,000. How's that sound? That sound like fun? Okay. Look at all these remainders here. Did anyone know that the remainder of 600 and 638 is 362? Does anyone care? Okay. Because eventually, am I going to be printing out all the remainders? No, print out the remainders. I'm just kind of building it. I'm building this program so you can see a method to my madness. Let's put 10,000. Let's put 100,000. Uh-oh. All right. View details. I've got 100,000 message. Actually, I got 100,001 messages because remember that original message we printed out that says, hey, you typed in 100,000. And we can go all the way down and you can see all these, right? This is just, but everyone gets the idea of what we're doing here, right? There's got to be a 0 in here somewhere, right? There's got to be. All right. But all kidding aside, we're going to type in something like 45. Did anyone see some of the weird stuff? Chima, you might have noticed some of the weird stuff going on there with those remainders, where that I'm making these integers, but those are 8-bit. We want to change those things to longs. So we want to change those to longs. Those are some things we heard in GIS back in the day, but let's not worry too much about that stuff because there wasn't enough precision to store those numbers. But we're just looking at kind of small numbers right here. Now, right here, when we see anything with a 0, 45 and 1, 45 and 5, 45 and 3, if the remainder is equal to 0, what does that mean? It's a factor, exactly. Okay, so now we got an if statement right here. We got an if statement that we're going to go to the next line here. And these if statements get indented. And so I'm going to look exactly. So I'm going to go here to my Python for GIS. Python programming. I'm going to go up here to my little if statement. I swear it's right up here. Here's a little if statement. If A is greater than B, colon. Now in small basic, we didn't have a colon there. What did we have? What word did we have there? We had the word then. And then we indented it and did stuff. And then we said end if. And so now this is a little bit different where that it knows that anything that's indented from this if statement, all it's going to do is just everything that's indented. So if I'm moving back and forth between this indentation, your computer's going to get your program's going to get really confused. Oh, this looks weird. How do I find that the long equal to sign? Because this is an equal to sign, but I see two of them together. What does the double equal to sign mean? Same thing as equal to. Because remember, we've alluded to the fact that this is an assignment. And so A equals B and B equals A aren't necessarily the same thing. And so now we're gonna write an if statement. I'm gonna use this exact guide. And what I'm gonna say, if, I'll go down a line, if remainder equals 0, check to see if there is a remainder between the number you typed in and the potential factor, because I'm doing this by what we call brute force. I'm just gonna check every single thing. In theory, I probably only need to go up to half of the number, because is 51, 52, 53 ever gonna have a remainder with 100? No. And so I could have cut down that calculation in half, but okay. So if the remainder is equal to 0, what do I want to do? Yeah, exactly. We want to print. We'll say, hey. So I'm going to do argpy dot add message str I is a Do we need to print anything else out if it's not a factor? Do we need to? No, not necessarily. We don't need to. Because I don't want to print out 10,000, any of these things. I just want to go through and pop out those factors. This is where we're at number 2 here. Print out the factors. And you can see the code here. So I've really tried to document this stuff right here, because when we go back and revisit this, we can see, all right, this is what Mulrooney was thinking. Do we need to do anything, is any sort of else if? No. Well, let's try running this thing here. Now, why do I have this STRI right there? Concatenate the string, okay? And I'll put print out the factor as a number. While we are at it, convert the integer to a string. Okay, does everyone know why I have to convert it to a string? Because, and those of you kind of joining us right here, it's like, I know what 23 plus 16 equals. It equals 39. And it's like, okay, I knew that. You know, but now when I do 23 or 16 plus the string, Mulrooney, it doesn't know what it is. Like, all right, you're an integer, you're a string. I can't add you together. Small Basic was able to do that. This can't. So all we're doing is just saying, hey, when I convert it to a string, I'm just putting little quotes around it so I can concatenate these things together. That's all the word, that's all that thing str does. And so when we have that input parameter that we type in, we go in the other direction, and I type in, 102, that's by default the string. Why? Because when you look at the top, it says get parameter as text. So once I get that thing, I say, hey, I'm going to turn that 102 to a 102. And that's what the little int function does right there. Okay, so I can go back and forth between these. Small Basic goes back and forth between them. It just says, I assume we're not adding strings and text together, and we'll just put them together when we use that text window dot write line, right, or whatever it's called. And that's just the way it displays input. So now what do we do? Well, let's run it first, and then we'll count the factors. Okay, so I'll go back to my program here. 45. I'm gonna run it. Uh-oh, view details. What'd I do wrong? ArcPy has no attribute add massage. What did I do wrong? We all know what I did wrong. I add message. Okay, and you notice that these are indented. So now I'm gonna run it. And while I'm here, watch, I'll just comment this thing out. So what do I have here? I got that original line that I printed out. And now I said 1, 3, 5, 9, 15, 45 is a factor. What's common about all those things? What are common about 1, 3, 5, 9, 15, 45? What's common about the remainder with 45? Zero. It's zero. Okay? And so the only way that these things are printed out is the remainder is equal to zero. Just for the heck of it. I'm going to type in 5,000. These are all the factors of 5,000. Now it starts to get ugly if I go above like 32,000, something like that, because it's no longer an integer and we need to, it's called a long. I'm not sure how we allocate longs in Python, but remember, do we use long? We just use the word long.
We should do it on the toolbox, like change it to use GP.
What's that?
GP.
GP long?
Yeah.
Okay. How do I convert it within the actual code itself? Is it double? I could probably just convert it all to double.
Yeah.
Okay. And I can also convert these to double precision, which are really long numbers that accommodate decimals. But here in the case, we don't need decimals. And we're kind of assuming, so there might be a long, I don't think there's a long, but I know there's a double command here. Okay, so we've got some of these small numbers. So, what about, all these other things here. And so we can figure out these factors. Now, the last thing that Chima alluded to is, hey, while we're printing these things out here, let's count the number of factors, because what we already did was check, we asked for a number, and we were nice enough to print out what the number was to begin with. We printed out the factors. Next, what do? Let's count the number of factors. And the first thing I'll do up at the top here is I'll just do something called count equals 0. And I'm just going to set a variable for the number of factors to be equal to 0. And so the only way that we're going to add to that number is if what happens? If the remainder is equal to 0, exactly. So we'll go here while we're printing things out. While we're printing things out, count equals count plus 1. And if you remember, we talked about this last week, and I think Chima alluded to this. Count plus equals 1. And all this means is that we are going to add 1 to the counter when we have a remainder of 0. Now we finally finish out the program, and then what do we want to do after that? Every time we go through, do we want to say we have 1, 2? We don't necessarily need to. When we run the program at the end, we'll say, hey, we have this many factors here. So next thing we need to do here, I'll go down here. Why do I have to go all the way back to this 4? Why do I have to indent it all the way back to the left? How am I going to indent it? Because everything in the for loop is gonna go here, everything in the if is gonna go here. Do I wanna keep printing things out over and over again? No. So it's gonna go back to this original justification here where we started with the program. What do you wanna print out? When we're done, what do you wanna print out, Mac? What's it gonna say?
The number of factors.
Count. Exactly. All right, so we'll just do an arcpy.add message. I'm gonna cut and paste this so I don't screw it up. What am I gonna add? The number of factors is plus str count. And then prints out the number of factors when we are done. Okay, we're gonna look at a couple of logical errors here. So watch this. I'm gonna go here. Well, we'll just type in 100 because we know that this should have an even number, odd number of factors. Right? How do I know it has an odd number of factors? I'm not that smart because it's perfect square. You know, because usually they're paired, so it's got it's perfect square. All right, let's just make sure this works. 1, 2, 3, 4, 5, 6, 7. Yep, 9, right? Okay, the number that you printed out was 100, so we asked the user for a number, we kind of regurgitated that back. We printed out the factors, and then we said the number of factors is equal to 9. Got a logical error right here. What happens if I moved this over? Well, let's try running it. It runs, but what happens? What's it doing? It's stuck in that loop. And it's gonna keep printing out the number of factors is 4 until it gets to 10. So it's stuck in that for loop right there, right? That for loop that we originally said was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Eventually we converted it to the remainder of this and this is this that we commented out. So it's just stuck in that for loop right there because that's the way Python works. Now, in small basic, how do we end a loop? N4. There's no N4 there. That's a little tricky. How do we feel about this? We get an idea as to the method here? Because I think I don't want to say hold off, but I got an assignment where we're going to start interacting with things with loops. We're going to make something, and we'll probably do it a little bit more next week, where we look at something called the null value checker. What do you think that's going to do? We're just going to go through a big column and count the number of times there are nulls. You think you can do that? Yeah. How many times are we going to go through? Oh, we got to go through the actual interact with the actual table. Interact with the actual table. Okay. So does everyone get the idea of what we're doing here? Why we're doing it? Because we're going to eventually get to a point where, and the next thing I'll do is I'm going to show you a program called the Jacquard Index Calculator, and then I'll let you finish up the homework from this week and next week, and then we'll talk a little R next week, and then kind of finish this up. Because I feel like people are, I don't want to leave anyone behind. It's kind of my big thing. You know, I don't want to make sure. So, does everyone have an idea what we're doing and why? What's the important stuff? What's that? Automation. We want to automate this stuff. Okay. And ArcPy, we did a couple things with ArcPy right here, but when we start looking at exercise number 5, we get in some real neat automation stuff. And I'll show you the kind of method behind my madness here, and then we'll talk more about it next week. And then we can kind of focus a little bit on R. I just want to make sure we touch on R because it's something that we hear about in this day and age. And I don't want, I need to be responsible enough to show it. So we wrote this code here. My big thing here is I debug using the print statement. I don't know if it's right, if it's wrong or whatever. Is that what you do, Chima?
Yeah, it's where's the S3 Python for.
Oh, okay. In that class, you just do the print
Yes, one of the
Oh.
debugging.
debugging methods. My debugging methods, I write a couple lines. If I can get there and print out stuff that makes sense, then program's running. And I get a little further, get a little further, get a little further. And so you can see these comments sitting here. One thing you can see are these comments sitting here where that now the remainder of blank and blank is that. Does that make sense that the remainder of 45 and 2 is 1? Yep, that makes sense. And so I'm using the right command right here because this little percent sign doesn't exist in small basic. I think they called it remainder, right? I forget what. A bunch of those math functions. Okay, and it's being called something different in C or Visual Basic or whatever other programs that you work with. Okay, this thing is called the modulo. Has anyone heard that term before? Modulo. M-O-D-U-L-O. Okay. And so we've got these input parameters. The other thing I want to make sure people understand, I'm going back and forth between strings and integers. Why? Because I just looked at the directions and it says, hey, I can't add strings and numbers, so I've got to convert. If I want to concatenate strings, Python isn't smart enough or not willing enough to add strings and numbers that small basic allows us to do. Because I would love to program in small basic all the time, but guess what? Small basic doesn't interact with ArcGIS Pro. R and Python and all these things do. Okay. And so this is the scripting language for it. Now, the next thing I'm going to look at here, do we want to take a break here? What do you say, Barbara? You want to, or we just want to power through, or what do you? Let's power through. Okay, all right, that's fine. Okay. So the next thing, because I don't want to give any homework today, just because I want to make sure everyone's kind of caught up with everything, because the next Esri exercise we're going to do is getting into some of the ArcPy. So I'm going to show you some of the things that I've done, a program that I've done, and I'm going to let everyone kind of play a little bit of catch up with the assignments, and then we'll kind of reconvene next week to make sure everyone has the hang of things. Now, so let's forget about this one right here. But within the homework for this week that I've posted is that, and within the homework that I've posted for this week is something called Jacquard maps. And I also have exercise 5. And if you look at exercise 5, it's kind of cool because what you're going to be doing is, this is the ARCS database. This is basically every single section of road in the entire state of North Carolina. Look how long it takes to draw. There's like 800,000 of them. And what we're eventually going to do is, it's got about 93 different variables. And within each of those variables, they're all supposed to be populated with something. And what you're going to do is you're going to click one of those variables and you're going to see how many times the word null comes up. And this is just kind of getting ahead of us right here. Okay, so what we're going to do is we're going to count the number of times null comes up. Like, hey, look at this variable, look at this field right here. I see the word null here. Because in theory, when we look at a lot of these data, we shouldn't have the word null. And so who wants to go and like sort these and then, or do some sort of selection, right? Right mouse click, select, query, all this. Hey, let's do a null value checker so that I can see the number of nulls here, the number of nulls here, the number of nulls here. And eventually, hey, you just did it now where it says, hey, record number 27,000, record number 23,000, object ID this. These are all nulls. You better go back and revisit these. You got to go check these for these particular counties. So we're going to look at something called a null value checker so that I can say, what are the values of nulls, 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 nulls. Now, how many times is it going to go through? 873,691. So even then, when when you run and do this, it's going to take a while to run. Secondly, we can think of more elegant ways than right mouse click, query, query, query. You can write a little tool that goes through and does this. Okay, and this is what I was going to have for homework this week, but we'll kind of push it off until next week. Now, how many times is it going to go through? 873,000. How many times did you go through the loop when I typed in 1,000? 1,000. Okay, 1,000. Now, what if I downloaded this and this next week and it had 900,000 records? How many times am I going to go through there? 900,000. So we're going to utilize ArcPy to just basically go through and how many records am I going to go through? Now this time we're going to take it from what? That feature class right there. So instead of you typing in a number, the input is going to be a feature class. And so remember, when we did these input parameters here in this exercise in Hello World, and this is just kind of getting to be, think big picture here. And I right mouse click and I go to properties. My data type, what are all the different data types that I can put in here? Can I put in a number? Nope. But I can put in a layout, an item, a file. Feature class. What else can I put in here? I swear. Field. So now you can specify the feature class and a field. And we can set up dependencies, meaning if you specify the feature class, you're going to have to open up a field within the feature class, because why would you open up a field in another feature class if you're not opening up that feature class? And so now I can just go to one of those fields and just say, hey, let's open that up. Let's go through. Let's count the number of records in there. Let's just go through that particular thing there. Now, do you think you're going to write all that code from scratch? No. What you're going to do is, hey, let's just see if this little value is equal to null. If it's null, let's count the number of times that it's null. And then when you're done, let's print out the number of nulls. Now, some of the things I've done with Python when I was working for the DOT was they want to see all the nulls. And I wrote a big text file that showed them record 27 was null, record 1,000,000 was null, record 500,000 was null. Those are really big files. These are called error logs. We're not going to do that in this class unless you really, really want to. No one's making eye contact, so I'll say that you don't. Okay, but we did a little bit of that in Small Basic, right? Could you open up files? Okay, you can open up, read files, write files, all that other good stuff. And so looking forward here, these are some of the different input parameters that we can have: layers, mosaic data sets, rasters, tins. I don't even know how or why I would use these. And then we use ArcPy to interact with them. Because here we just got strings. The only ArcPy we were really doing was ArcPy.addMessage. So what I'm going to do here is I'm going to open up this thing called Jacquard. And it should be under course modules. If we open it up under week 5 materials, and this thing is called Jacquard. Those of you who know me are really sick of Jacquard because this is like my baby and this is my contribution to the world of GIS, but no one likes it. But I'm going to explain what it is because those of you who've taken statistics, geostatistics, have a good idea as to what we're looking at here. And so when we look at maps right here, okay? We look at maps, and a lot of times, if you've taken remote sensing class before, you could, if you've taken remote sensing class, data are classified certain ways. Deciduous forest, developed grassland, wetland. Now, you can just see here, this is a hypothetical 10 by 10 lattice for fishnet. Remember those fishnets from Geostats? We went and generated those fishnets and did all those counts with the spatial joins. And so we extracted this and I put them into one of 4 different categories: deciduous forest, developed grassland, wetland. Who determines what class something's gonna be. This gets deep real quick. Who's taken remote sensing before? Has Mac taken remote sensing? Oh.
What was the question?
Who determines what's grassland or developed or wetland?
We do.
Stating the number.
We do. Oh, what'd you say, Caitlin?
We do.
We do. Okay. And a lot of times algorithm does, because when we look at the, excuse me, the reflectance patterns, we look at these digital signatures and all this other stuff that get out of my skill set. And so we can use, because we're not going to go classify these by hand. And so we can look at the time of day and digital signatures and things that our eyes can't see. And depending upon the algorithms that we use or the time of year and all this other stuff, we can look at these. Now, what I've got here is a couple of different classifications. Okay, and so you can see one here. This is using a fishnet. This is called, this is from something called NLCD, and this is from like a base map or something like that. And I look at these right here. What are the chances these things are similar? How close are they? How far are they? Because we're working, at the end of the day, we're working with nominal data or categorical data in this case, I guess. And one of the things we have, a lot of times we have trouble is going between some of these things. And when you open this up, when I go to downloads and I go to my week 5 right here, these are some of the things that we've got here where that I've got all these different scenarios of maps, meaning, okay, I've got 2 maps right here. Are these 2 things similar to each other? I'm getting real deep real quick, huh? What about this? Okay, look at these here. I've got, these are like literally like opposites, right? What are the chances that I happen to have like 50 of these and we would have this pattern and this pattern that are totally opposite? Because what we want to try to do is see how like phenomena are. How likely are they alike? Meaning, does the red-cockaded woodpecker habitat coincide with some certain type of tree? You know, and what are the chances? Because they should have some degree of overlap based on random chance, right? Isn't this what we started talking about with the two-tailed t-test? What does a two-tailed t-test really do? I'm getting real deep. Oh, so someone's like, oh, what the two-tailed t? I remember this. I remember this. 2 sets of data. Because in theory, if we had 50 from one batch, 50 from another batch, and we were looking at the attribute of one of them, say income, in theory, they both should be the same, right? They should be the same, and the normal distribution curve of those should be the same. Now, if they get far enough away from each other, the means in that distribution curve, when we look at things like standard deviation, or in this case, I think it looks at the variance, in theory, it should be, you get far enough away, we can say, hey, there's a lot more than statistical chance. Because a lot of times if we say, this neighborhood has an average income of $50,000, this one has an income of $51,500, is that far enough away from each other to be statistical significant? No, because we have random sampling errors, all this other stuff. If it's $50,000 and $60,000, we're starting to get statistically significant. So we talked about some Excel functions that do some really simple two-tailed t-tests, but you can bring these into R and SPSS and everything else. Okay, I stress this because the two-tailed t-test is my go-to tool. You know, I've got high access to food, low access to food. What's the difference between percent African American, percent young, percent Hispanic, percent Native American, per income, all these other things to see if there's statistical differences between those. So at least I can say, hey, these low access areas have higher percentage of this, and this. And I see some real synergies with what Chantel's going to look at, where we look at gun violence crimes. Hey, let's look at the gun violence crimes percent or number in the by income or race or whatever. So we can say, hey, here are the 223 223 zip codes that had a gun death. Let's look at the 427 that didn't. Is there a difference between age, race, income, other things that can be collected? So she can say, hey, in areas that have this younger population, or maybe even older, I don't know. And that's the good thing about it, is we don't know. What are some of the associations between these? But that's kind of my go-to tool, where let's look at the gun versus the not gun, or high access to guns, or we look at gun death rates and we kind of split. Let's look at this end versus this end to see if there are any differences. So this is my big go-to tool. And any of the papers that we've had, you've noticed that I use that two-tailed t-test. It's not because it's because I like it, I'm good at it, and that's the tool I use. So that's my diatribe on the two-tailed t-test. And hopefully you're going to go and kind of find the statistical tool that you want to do. I start to integrate those with geostatistics, where I got, all right, let's look at the hot spots of gun deaths and the cold spots of gun deaths. So now, instead of lining them up with the two-tailed t-test, I can let me look at the percent African American, percent Hispanic, or percent young by the blue versus the red, because there's a whole lot of yellow in there, because blue and red represent hot spots and cold spots with statistical significance. And typically, what does statistical significance represent? What p-value? We're getting deep here. We did this last semester. I don't want to talk about this anymore. What's the statistical significance for p-values? 0.1, 90%. So 90% in either direction. And so when we look at a map of hot spots and cold spots, most of them are yellow because they're between that 0.1 in both directions. Everything can't be 0.1. Better not be, or you got some real wacky data, really wacky data. All right, so when we have two phenomena, it's really going to be, what are the statistical chances that they're going to be opposite of each other? Really small, right? When we look at random phenomena, in theory, they should have some type of coincidence or overlap or something like that. I think this is scenario one, right? So a lot of times when I look at something like the red-picated woodpecker or whatever, I see something like that. What are the chances I have a phenomena that looks like this and a phenomena that looks like this, that they're geographically similar? Pretty good, probably, right? They're at least geographically similar, and I can let everyone else figure out the why, whether it's the gun or the food access or whatever here. Figure out the why. Okay. All right, so what I did here is I created a tool here. I'll open up the tool, and I think we're just going to kind of finish up and maybe start thinking about some things next week here. And I'll let everyone kind of play some catch up with the VB and the Python and everything else. So I'll go through this code a little bit here, but when I click open, look what I have here. I have got an input layer, and this could have been a feature class. I've got two fields, and I have something called binary vectors and sets, but binary vectors basically look for presence and absence, while sets are going to definitely have to have something here. And so a lot of times we have nulls and ones, or we have like 0, 1, 2, 3. Because I think I showed you a scenario right here. It's getting deep here. I'm going off the rails. Where I look at, are these two phenomena similar here? No. But if this was red and green, where they were distinct, they'd kind of look similar, or there would be a lot more spatial overlap with the green, but this is presence and absence. So these are nulls and ones versus 1, 2, 3, 4, 5, 6, and that the Jaccard index does. And so what I have here is I got an input field. I've got a couple of different fields. I do the different types of calculation. And we're just going to look at this code here, and then we're going to go and let everyone finish everything else up. All right, so look at all this garbage I have here. We should know what this is, but here, very first couple lines right here. Input layer equals get parameter 0, get parameter 1, get parameter 2. What do those things mean? The field, so the actual field, and I call them different fields. And so if we kind of revisit our ArcGIS, we revisit our ArcGIS Pro right here, essentially what we're looking at is base, random, and LCD. So this is kind of like a base map. I threw a random variable in here in NLCD. So basically I'm comparing this column to this column. Okay, this column to this column. Can you compare columns in Query Builder? You can. It's not as easy, you know, but you can compare these. Because basically, hey, does this column equal this column? Does this column equal this column? Let's count the number of times these things coincide. Can you do that? What we call hand jamming? Yeah. Well, you want to write a tool to do it and get your master's or PhD? Yeah, that'd be cool too. And so I've classified these. And when we open up our code, I'll give us kind of just a quick little look. So like Chima said before, I've got a field. I got A, B, C's. I've got fields equal field 1, field 2. And so this is starting to get into what we call ArcPy right here. So I've got a variable called field 1, field 2. And if type field equals string, what do you think this string thing means? String, right? If it's like field or whatever the name of the field is. This is just saying, hey, let me make sure this thing isn't a 0 or 27 or you typed in something silly. And all we're going to do here, do you think I typed in any of this stuff right here? No. And I just found this. I put all this stuff right here. And so if the field 1 is equal to a string, all I'm going to do is search the cursor, the input layer for what? Whatever the name of that feature class is, the field, that's cursor, and all I'm going to do is for row. Did we already do a for loop yet? What do we count from? 1 to what? 100, whatever number you typed in. The same thing we do here for row and cursor. This is just going to go to the end of the file. 893,000 times, 100 times, 87 times, 5 million times. Row dict, I don't know what this means right here. I took this from something. What's it mean?
Dictionary.
Dictionary, okay. And so, I call them type 1 and type 2. And all I say is that if the first column is equal to the second column, I'm going to add those two things up. And I'm just going to count the number of times they add up. That's what I do. Okay. Else, I'm going to count the number of times they don't add up. They're not equal to each other. But does this stuff kind of ring a bell right here? This equal to sign, I've got an if, I've got an else right there. Else, ArcPy, search cursor, and then I'm going to go and add a message that basically counts it. So and so else, now I'm going to go through and if the string is equal to, if it's equal to 1 and the row is equal to 0, it's going to do some other things. Okay, but extract keys, list 1 size, list 2 size. But you can start to see some of the things that we're doing here. Because what I do down here, all I do is calculate probabilities, meaning basically I'm calculating the probability, like this thing overlaps, 67% of the time. And so I look at some of these probabilities expectations, these things called centered coefficients to what it should be based on, I haven't accounted for sample size and all this other stuff here. But what we're gonna look at next week, what we'll start looking at next week is the main thing that we're doing here is we're gonna loop through the database. We're just gonna go through and loop through the database. Does anyone remember that iterate database I had last week? All this is gonna do is just loop through the database. And that loops through the database for the each of the feature classes. Remember how many times did we go through the database? As many feature classes as there are. Now, how many times we're going to go through? As many rows as there are. Do you have to write this from scratch? I don't know this from scratch. I don't even know what this stuff does. Okay, this dictionary stuff does. Because you can reference them a couple of different ways. Okay, when we pull from these fields. Because I know when I previously did this in Python, it didn't work quite as nice here. So now when I run this thing here, my input layer, I'll click on this little database to card map. I'll call it my little fishnet here. These are my fields that I have here. I'll call the base, the random. I need a type of calculation. I'll calculate it as a set. And look at all this output. Still running. And so I did some print statements right here, but look what it did for me. It counted the number of deciduous forests in the first one, counted the number of deciduous forests in the second one. It gave me the list size. And so these are pandas. These look like pandas, right? So I brought in these things called pandas. Python number dictionaries, something like that. Yeah. And so I brought in these things called Python number dictionary so I could kind of map the frequencies of each of these, because eventually what I'm gonna do is kind of compare these things to each other to see if they're the same, while I'm also looking at the actual card index to see if they're equal to each other. Because if I have a different arrangement of these right here and this number is really low, it's just random chance. If this number is really high and they were about the same number, we can do this. So these are the potential that you have here. I did bring in these pandas right here because I was doing a little bit of work on this, but down towards the bottom, yes. Yes. Man, I surprised myself I do this. But these get into the pandas, type 1, type 2, where how many different values are going to be in that array? Depends on the different types. Let's not worry too much about this stuff here, but I think we should have an idea as to some of these other things right here, right? These if statements and all this other good stuff. All right, how about I end it right here? Does that sound good? We want to play a little bit of catch up, and if you really want to play with that program we did today, do a couple of different things right there. Play with it. The only way to get good at this stuff is to do what? Try, mess it up. Do you see how I did? I just used the print statement. All I did was, let me open up the program, print hi mom. Okay, run it. Yes, we got the hi mom. Next, get the number. Hey, you typed in this number. Okay, we're at the second line, the third line, and the fourth line, and the fifth line. We probably put, probably about 10 or 11 different print statements so that we could ask for a number, print out the factors, count the number of factors, and we put them in the right place. If something doesn't look right, do some trial and error right here. And so if you want, I'll post this code that we did, and I'll stop talking because I get into this stuff here, and we'll call it the day here. Okay, so for next week, I'll post an announcement once I post the recording. We'll kind of push everything, the next assignment to next week, and give everyone a chance to kind of catch up on all the assignments, turn in the Python, brush up on some of your Python skills. If you want to look at some of my Panda stuff here, I think, Andy, does this stuff ring a bell? Some of the pandas and all that? Well, I know it does for Chima, so you could probably improve, you all could probably improve some of the things that I've done here. Well, I'm printing out dynamic keys and all that other stuff, but this is kind of what I do on the side, so. All right, be on the lookout for announcement tomorrow, and then we'll pick up with homework number 5 next week, so we'll see you all later.
Can I ask you,
Okay.
can I ask you a quick question?
Is it a hard question or an easy question?
It's not about this class, so it makes it
Okay.
easier.
All right, let me stop recording, so no one has to